Hey everybody, so in this world, where's Waldo of chaos here, you can kind of see this Lagun vertical mill. So previous video had to do with setting up a variable frequency drive on this mill. That now works. I can turn the mill on with this switch in the wall next to the mill. I can then wait for the VFD to boot up and I can turn a switch and it comes on. And I have some speed control here by turning this dial. So if you're really a potentiometer, but if you're curious how I did this, tune into the other video. The next order of business is going to be installing a DRO kit on this. And what is a DRO? DRO stands for digital readout. So to operate this mill without a DRO, you'll notice that these dials down here, the hand cranks, which you can barely see, but hopefully you can see better now, the only way to measure the position of the end mill relative to the table is to look at the numbers on these dials. So as you can see, as you turn this dial, the numbers move, and you got to count how many times, or I guess how many ticks you're going. So going from 120 to 130 on this mill is 100 thousandths, I believe. I don't have my glasses on. No, I'm sorry, that's 10 thousandths. Where is it? Hang on. Well, regardless, I mean, whatever, there's going to be some kind of graduation. You can read that and you can figure out how far each axis moves, okay? Again, don't have my glasses on. I can't even read it that well. Just part of the reason why I'm doing this. So instead of reading the dials this way and taking into account backlash in the movement and the lead screws, you can install a DRO, a digital readout. As its name implies, there is going to be some kind of display, maybe up somewhere around here-ish, that will actually measure or keep track of where the table is. So I don't need to even pay attention to these dials anymore. So benefits there if you're in an environment where you can be distracted or you just don't want to have to pay attention to those ticks and those dials. Or if you're concerned about backlash in the machine, in the mechanical system. All mechanical systems have backlash, and as you turn this dial, there is some amount of movement in this dial that does not result in table movement. As the machine wears out, that tends to grow bigger and bigger. This machine is fairly minor because, again, I think it's been used lightly. But regardless, the DRO doesn't care about that because it measures the position or keeps track of the position of the table, not the position of the dial. So what does the DRO kit consist of? It consists of, in my case, a set of scales. These are glass scales that I purchased off eBay. These are Ditron. So I have a scale for the x-axis, the horizontal axis. So as the table moves left to right, I have a scale for that that's going to measure. I have a set of Y scale, or I have a Y scale that measures the table forward and back, and also a Z scale that measures the knees position up and down. The remaining scales are behind me. They're not on the mill right now, but I'm going to start with mounting the x-axis scale. To begin that process, you can see that I've marked a vertical line here, exactly 4.625 or 4 5/8 inches in from the edge here, and the same on the opposite end of the table. I've done that because this table is 44 inches long, and the scale that I'm installing is 34.75 or 30, I think it's 34 3/4. Whatever, I mean, the difference between the length of the table and the length of the scale divided by 2 works out to 4 5/8, and that allows me to center that scale on the table. So you can see this mark here, this vertical silver mark is just a Sharpie. This is the one edge of where the scale is going to go, and again, there's another mark on the opposite end of the table. So I've got my scale lined up with that mark here on both sides. I just have my my lovely woodworking tools just kind of holding things very gently in place. I'm not clamping tightly. These scales are probably fragile. I don't want to break them. So now what I'm going to do is I'm going to center punch this slotted hole here and the slotted hole at the opposite end of the scale that you can't see. And that will allow us to mount allow us to know where to drill the hole in the table to then tap and then mount the scale to the table. So we'll need to also drill some corresponding holes for the sensor, which does slide back and forth, but we'll do that next after we drill for the scale. So here is my punch. What we'll do is we'll get it so my head is completely in the way and you can't see. Get it kind of centered up and down. There is some adjustability here, so these don't have to be perfect. And then we'll just press. And of course, that's not going to work because there's not enough travel. So I might need to do this one the old-fashioned way with a hammer and a traditional punch. So let me dig that out of the toolbox and we'll go and we'll punch these. Got the old-fashioned punch. Just give it a tap to mark where we need to drill. This is cast iron. It should be pretty soft. Just marking the other side in the same manner. I'm going to use my spring-loaded center punch to just kind of refine these marks a bit. Now it's time to drill the table. All right, it's a couple days later and some more materials have arrived. I've decided I'm going to use the metric 5 by 0.8 screws, the longest ones that come with the kit. They come with matching washers. Hopefully you guys can see those. These screws. So 2 long screws with 2 washers that match comes in the kit. And again, they're metric 5 by 0.8. So to prepare a hole, I have a 4.2 millimeter drill bit right here. Also have some a tap and die set, or I guess a tap set. So I have a 3-piece set. Again, I'll leave links to all this stuff in the description. So got it on Amazon. And it comes with 3 taps, all a little bit different. So one of those is designed to start the hole, the other one's designed to cut threads all the way through a through hole, and the last one is the one that's designed to do like, I call them a bottoming tap, so a hole with no end. So I guess let's stop yakking about this and let's get started with the drilling. Okay, I got my drill bit in the chuck. I'm going to use a little bit of Tap Magic cutting oil. Hopefully make the drill last a little bit longer. Let's get to it and try and drill as straight as I can. Not in hammer drill mode. Should be pretty easy because it's cast iron. Stop once in a while to reapply the oil. And keep drilling. Getting there. Probably as deep as we need to go, but we'll go a little deeper just to make sure we have enough. So we drilled about that deep, maybe just under an inch. Okay, we've drilled about that deep, and that's more than the stick out or the bolt behind the scale. So now the next step is to actually tap threads in there. And we're going to start with a taper tap. Make sure we get the right size. I have a bunch of different sizes here. Yeah, got it. Okay. So we're going to start with the tap, and these are the 3 that are included. We're going to start with this one here. Let me get a tap handle and get started. Throw a bit of thread cutting oil in here, the Tap Magic. throw a little bit in the hole too. Get started. I'm going to cut these threads as straight as you possibly can. And cast iron is usually pretty easy to thread. So you see I'm turning and I'm backing off to break the chip. And once you get a bunch of threads cut here, I like to switch over to the bottoming tap. That'll allow you to go pretty close to the end of the hole. These are not super high quality taps. They do still have points on them, but it is what it is. They were cheap. I'm not making 1,000 of these holes. So this is that bottoming tap. Notice it doesn't have a point on it. Throw some oil on there. And that's about it. So now we'll unscrew this tap and clean the chips out, some compressed air. And then we'll bolt the scale up and see how it fits. Yummy. Got the hole all cleaned out. Let's test fit our screw. Yeah, it's going to work nicely. Let's try bolting our scale up on this side. We have some side-to-side, up, down adjustment, which is great. Cool. All right, that side's done, and we'll just rinse and repeat and do the other side. I'll do that off camera. I used a 1, 2, 3 block and a square to just mark some vertical lines down here on the, I guess this is the saddle or the knee. I don't know. I don't remember all the names of the parts of the mill, so I know where to locate the reed head. So these two lines should be perfectly centered across this y-axis here. So now we just got to mount the scale with the reed head attached, mark, drill, and tap those holes. Interestingly, the screws that come with this this kit don't seem to be long enough. I don't know why, so I ordered some longer ones. Should be here tomorrow, but I figure at least in the meantime we can get things mounted. So let's get this thing bolted back up so we can mark those holes. Then we'll take it back off again to actually drill them. It's important that that reed head be located pretty precisely. I'm going to take the time to actually indicate this scale in place so it's perfectly parallel with the bed too. And I'll show you how to do that in just a moment. Just kind of snug these bolts up a little bit. Let's move the bed back over. Table rather. Now what we'll do is we'll get a dial indicator and we will indicate the top surface of this scale. Much as it pained me to remove a perfectly indicated vise, kind of need it for this step. So make sure your table's really clean. And we'll take a dial test indicator, mount it on magnetic base on top of a 1, 2, 3 block, and we'll just run the length of this table indicating this this scale. We want it to be perfectly parallel to the table. Can we do that with this setup? Gotta be a way. Let me mess with this a little bit. Something like this. So what you want to do is get your indicator, dial test indicator, set up on a little stand like this, and you want to make sure that the reading here is the same as you glide down the surface of the table. Again, you have to make sure the table's clean for this. Just like that. And you may need to tweak the position of the scale here or at the other end, depending upon how that indicator reads. So this dial test indicator, each tick on it, or each gradation on there is at 0.5 So I'm at 0 right down here. Now I'm at like plus, I guess maybe down down a thou, back to 0. Holding pretty close to 0, and maybe another thou. So the allowable tolerance on this is 0.15 millimeters, which is 5 thou. So we're right on. Actually, miraculously, this thing didn't really quite require that many adjustments. I was kind of surprised. I had it pretty darn close right from the get-go, just aligning it to the bottom of the table. So that's a pretty important thing to get right, though. Spend the time, make sure you nail this dead on, because otherwise that read head is going to be in different positions. Different positions relative to the scale, obviously. All right, now that we've got that aligned, next step is to unscrew the read head from the scale bottom so we can slide it. Then we gotta mark it. So take these little baby screws out with one of those micro screwdrivers. And then gonna need a punch. My center punch doesn't fit those holes either, so I'm gonna have to wing it. Let's move our read head down this way. Let's try to get it within the confines of those marks there that I have on the frame of the mill. Get it as close as you can, and we'll pull up on the sensor to make the gap consistent. We'll use our punch to mark it. This isn't going to be long enough, is it? No, it's not. Oh, man. Okay, I found another punch. I just ground a tip on it here. That fits the hole right here on the read head pretty nicely. I just clamp the read head in place just so we don't have to worry about holding it. So we'll just whack it with a hammer. We'll do the same thing on the other side. Those will be our marks that we drill. Let's just make sure the marks that were made are good enough. Just slide aside, and yeah, I can see and feel those with my finger. Now that we've got solid marks there, let's take the reed head off again. Probably don't have to do this, but I think it's just going to be easier to see what we're doing if it's not here. We'll have to re-indicate it again, obviously. And then we'll have a much clearer path for drilling. All right, the screws that I'm going to use arrived. They are, I believe, 25 millimeter, excuse me, I think M4. Yeah, M4 by 25 millimeter. Going to be using a drill that is 3.3 millimeters, and I have a, let's see, it's an M4 by 0.7 tap. So let's start by drilling the holes. Not sure if you guys are going to be able to see because my body is going to be in the way, but we'll do the best we can. I have the ways protected with this rag because there's going to, I mean, stuff's just going to get on them, just the way it is. Let's just throw a little bit of cutting oil in here. Let's see if we can do this without, yeah, you guys aren't going to be able to see much, sorry. You get the idea. Okay, I got that hole all drilled. Let's get our tap. I think I got the same type of set as before, just a little more subtle, difficult to see. Let's get our tap wrench. Throw a bit of cutting oil on there. This Tap Magic stuff is great. Switching over to the bottoming tap. A bit of cutting oil on there too. You get the idea. I'm going to drill and finish tapping this one, drill and tap the other hole, and then we'll pick it up and we'll mount the reed scale together. Or the, sorry, I can't talk today, the X scale together. Okay, I got the scale indicated in. Let's move this thing over to the approximate center line. I realize you can only see my head, sorry. Let's get our screws. And we'll bolt this thing in, see if it works. Let's get our other bolt. Thank goodness they line up, right? That was a bit scary. Okay. Table still moves. Now let's take out those tiny little set screws that hold on this plastic spacer. One. Two. Now this plastic spacer should just come out. Should being the operative word. A little tight. Let's loosen this a little bit. Maybe if we move the bed, that'd help. You know what, I think I gotta take the washers off of these screws. I think they're a little bit too big. But of course they don't come off. Fantastic. A little tight. Let's loosen this a little bit. Maybe if we move the bed, that'd help. You know what, I think I gotta take the washers off of these screws. I think they're a little bit too big. But of course they don't come off. Fantastic. Just loosened the screws. Pulled the spacer out a little bit. We'll get them snug again and we'll see if the spacer comes out then. Hopefully it cooperates. Yeah, there we go. It'll come out. There we go. That's it, folks. Next step is to hook up the DRO and actually test the thing, make sure it works okay. Following the same general procedure for the Y-axis, this mill has some holes here, 3 of them actually, one here, in this middle, and all the way in the back. They're not threaded or anything. I'm not really sure what they're designed for. They go all the way through into the knee. So I'm not really sure. Maybe they're to mount a DRO kit that's designed specifically for this mill. I'm not really sure. The holes in my scales didn't line up with these holes, so I'm just drilling new ones. I did try to put a stud in here, but I felt like it was going to be more work than it was worth it, just thread and tap new holes. So we're just following the same procedure we did for the X-axis for the Y. This is a little bit less scary because these holes do go all the way through the knee. So you don't have to worry about chips binding up or any of that nonsense. So let me get these drilled and we'll pick it up from there. Give it a quick little deburr. And the knee on this mill is a little bit of a curve to it, so we're probably going to have to do something about that because we don't want anything bending or reading crooked. So what I'll probably end up doing, it comes with these little shoehorn shaped things, little spacers. So I might throw a couple of those back there. I think the challenging part on this project is really going to be mounting the reader, because we're going to have to make a bracket that comes out under the knee, swoops in, and, well, I don't want to get ahead of myself. You'll see when we get there. Okay, I got the Y-axis read scale mounted. It's still loose. I gotta, true it up and everything with the dial indicator like I did the other one, but it's mounted. It'll do. So I guess we'll pick it up, and after I true this thing up, and we'll figure out how to mount this reader to the underside of the table. Should be interesting. We'll have to fabricate something, I think. The brackets that come with it don't work out. I think I got the Y-axis all mounted and ready to go. So the DRO scales come with these brackets. I didn't end up needing any of them for the X-axis, but I ended up needing 3 of them for the Y-axis. None of the brackets worked out of the box. I had to modify, let's see, I had to modify this one here. I ended up using the mill to, there used to be I guess it was, do I have another one here? Yeah. So this bracket here used to look like this. So you see there's a groove or a slot in the threaded hole. I milled just by eye. I didn't bother to measure anything. I milled by eye this groove all the way down and got rid of that threaded hole at the bottom because I needed the extra height here. You can see these are pretty much at the length, the extent of their travel. I didn't have enough metric fasteners, so I widened these grooves to 1/4 You don't necessarily have to do that. The fasteners that came with these things were short in almost every case, so I ended up using a lot of my own fasteners. So again, I used 1/4 right here. These are the fasteners that come with it, and I ended up finding some spare fasteners up here too. So let's see, what else? I think I modified this bracket as well. I think I chopped it down. Yeah, and I drilled this hole out. It was, I know you guys can't see it, but it was a threaded hole, as you can see there, 2 threaded holes for metric threads. I ended up turning those threaded holes into grooves sideways, like that, and hogged it out so I could fit a 1/4 bolt through there. So, it would have been nice if this is more plug and play, but I get that these things have to work under pretty much any scenario and lots of different machines. So I get it. It was work. So anyway, it's done. I'm going to put on the cover for the Y-axis scale next. It's right now just kind of sitting there unprotected. I did already drill and tap the holes for doing so. And I did design this bracket such that I could slide this thing under there without removing anything, just for my own sanity and convenience. So we'll just slide this under here. And that kind of covers things nicely, and I'll bolt that all up. There we go, all nice and protected like the X-axis. That's on there pretty solid. I don't know if I mentioned it before, but I did have to add some spacers behind this and also behind the scale because that casting is not perfectly flat. It's not a machine surface. So I think now that we have both X and Y, the most important axes hooked up, we can boot up Touch DRO and see what this thing can do. I have not used the app before, and I have not used the DRO in over 20 years, so probably be fumbling with it a little bit. Let's crank this table over a little bit. Do still have to mount the Z-axis scale, but that's far less important because that's something that use far less on a mill, or at least I do. All right, let's do our calibration procedure. So I have 1, 2, 3 blocks set up on the mill. I used my dial test indicator to make sure that this 1, 2, 3 block was perfectly perpendicular this way. So perpendicular to the axis of the X travel, so it's perfectly parallel with the Y axis. So the first step in doing this, I've got, well, actually, let's start the calibration procedure. So to do that, you have to go into Touch DRO. There's a little hamburger menu. I think it's what the young people call it these days. Up here, go to Settings, going down to the X axis, because that's what we're doing. And next to primary input, all the way over here, hopefully you can see there's a calibrate button right where my finger is. I'm going to press that. It's asking about how big the block is. I'm going to do a 3-inch block because we're doing the 3-inch side of a 1, 2, 3 block. We'll hit continue. It says to locate the left edge. So I'm going to come off it. I'm going to bring it to the 0 mark on the dial test indicator, and I'll show you that. So I'm just turning this handle until that needle zeroes out. Of course, I'm going to turn the right way. And right there. Okay. And I'll hit continue. And it's going to sample the scales for a little bit because they might be a little jumpy. So I'll wait for this to finish. Realize you guys can't read that. It says to locate the right edge of the calibration block and continue. So what we'll do is we'll move the table and we're going to come into the side of that perpendicular block. So we're going to indicate the edge of this block. Obviously these blocks have to be close and touching. There can't be any grit on there, so make sure that everything's nice and clean before you even bother doing this. Moving the table over, and then we'll hit 0 on this axis as well. Ignore the beeping, that's just telling me it's a past 0, I think. Get away from that. There we go. So let's sneak up on that. All right, we're perfectly at 0. So I'm going to hit continue on Touch DRO again. And it's doing the same thing. It's sampling the scales. Wait for it, wait for it. And if everything goes well, it should display a message like this. So we'll hit apply. So now that should be the calibration procedure for the x-axis. Got the x-axis zeroed. So let me try to move the table 1/1000th of an inch as best I can. Just looking at the dials, that's pretty close to 1/1000th. Yeah, so you can see 0.00118. So pretty darn close. I don't think we're going to get much closer than that on a mill like this. Now we have to follow a similar procedure for the y-axis. This is the procedure I use to square it up. So you can see the dial test indicator as I'm moving the table in the x direction. It's changing. You can get it pretty close with a machinist square, which you can see right there. But obviously that tool is not perfect, so we need to adjust this. What I like to do is I'll put the dial test indicator about in the middle. I'll zero it out, get it pretty close, then I'll zero it the rest of the way with the hand dials. And then we'll run it in one direction and see how far off it is. Okay, so we are maybe 10,000ths too far out on this side. So we'll give it a light little tap. Maybe a little heavier tap than that. Do I have something heavier? I got something around here somewhere. There we go, a little screwdriver. So I'll give it a little love tap. Might be a little too tight on that clamp. Loosen the clamp up a little bit. You can see it moving ever so slightly. Now we're about 5/1000ths out. Let's come back to center. This side's about 10,000ths too far in. So really just got to go back and forth, knocking this thing and adjusting it ever so slightly. Okay, got it towards maybe a thou or two out, but we can get a little more accurate than that. Just keep on tapping ever so slightly. That's actually pretty darn good. That's close. Still minor adjustments. Let's see, we're dead on 0, 0. That's like just under half a thou. I'm happy with that. And again, let's make sure our table's nice and clean. Our 1, 2, 3 block is nice and clean. Make sure we snug this up back here. Probably best to recheck after adjusting any clamps, so I'll do that real quick. Yeah, we're fine. We're still under 1/1000th off. So let's get our block back, clean up all the surfaces. And now we'll do the same procedure for the y-axis. Move you guys back a little bit. All right, let's do that same calibration procedure. Going to go over to settings again. This time we'll go to the y-axis. And we'll go to this calibrate button here. Put the tablet down. Whoops. That's probably not going to work. So I'm going to enter 3 here. Continue. And we'll bring this to 5 on the dial test indicator. We are dead on it. Let's hit continue. We are sampling. Sorry about all the reflections with the lights. Not much I can do about that. Can't work in the dark. Okay. We'll come off of that. And we'll come over. And then we'll locate back here too. We'll bring this to 5 on the dial test indicator, just like the other one. Okay, that's dead on. And we'll hit continue. It's going to sample again. Wait for it, wait for it. Okay, we're done. Okay, that is the calibration procedure for the X and Y axis on this mill. I'm going to take some time and get the Z axis mounted, and then we'll go through the same procedure again. Wait, did I miss? No, we're okay. Thought maybe I hit the wrong thing there. Yeah, so let me get the Z axis mounted, and then we will go through the same procedure there. A little bit of progress. I got the scale mounted. I don't know if you guys can see, but I made a couple of spacers. There's one up here at the top, one there at the bottom. They both are kind of variations on this one, which I accidentally made too small. Really all it is used a piece of 1-inch aluminum rod, cut it down to like maybe 800 thou, 850 thou or so in diameter. Drilled a hole through the center for the mounting screw. And then you can see here at the top, hopefully, I milled a 5-degree bevel on one side because that casting is irregular. So this kind of matches up with the, or kind of mates up with the irregularly shaped casting. It's not really irregular, it's just not out of square. So this flat side goes against the DRO scale. This angled side, around 5 degrees, goes against the column casting. And yeah, so just cut those to length. And what I'm doing now is I'm just running the knee up and down with a dial indicator, making sure that needle doesn't move. So the full length of travel, it's moved about a thou and a half. So I'm pretty happy with that. I might tweak it just a little bit, but overall, that's pretty close to where we want to be. I'll get you a closer up video. There's another view of the same thing. So against the flat spot of the spacer goes against the back of the scale. The angled piece goes against the casting right here, and you can see just over a thou out in the full length of travel. So let's see, next step, I got to make sure that the scale is perfectly parallel to the vertical axis in the mill. So I'm going to run a dial indicator on this side and see if we need to move the scale side to side a little bit. It's fine forward and out, but we need to measure it side to side. So I'll do that off camera. Okay, I got the scale dialed in perfectly. It's got it less than a thou run out in every direction along its axis of travel. Now I used Touch DRO on the X and Y axis. I got those running already, calibrated, to mill out this bracket that comes with the scales. So before, this is kind of similar to what I did on the Y axis, but previously this was a groove right here and a hole, groove and a hole. And what I did is I just extended this groove all the way down here. I think the total length of this groove is about 900 thousandths. So that allows me to have a little bit of extra travel on this bracket. Because before, when I mounted the bracket, let me get you a better camera angle. I don't think we need the dial indicator anymore. We can take that off. This is just a cheapie. Got a couple of these. You don't need an expensive dial indicator, but if you have one, use one. So this bracket's going to go something like that, right? And before, because this groove was smaller, this bracket wouldn't extend far enough, and it was like just touching the edge here. Didn't really give us enough room to bolt something to the side. So I'm going to get a plate and bolt this at a 90-degree angle right here. I'm going to probably get some aluminum stock and tap it to allow us to mount, will allow us to extend this bracket over to the reed head on the scale. Did some work off camera and got this bracket that comes with the DRO scales. The kit got this mounted to the knee right here with 2 screws. And I took this piece of metal right here, this bracket that also comes with the kit, and widened out these grooves, just like I did on, I think it was, yeah, it was on the Y-axis. And I made this piece right here from scrap I had laying around. It's like 1/2-inch aluminum plates, overkill, like way overkill, but I had it laying around. I drilled 2 holes through the end right here and here. I think there was M5, spaced roughly, I think 1/4 inch in from the edge. Tapped it, 2 screws, and here on this end, this goes into the reed head over here, and I milled 2 slots, vertical slots, up and down here and here, for M5 screws as well. So now everything is attached, everything is rigid, and I re-enabled the scale in Touch DRO, so now we just have to calibrate it. This wasn't too difficult to build. I mean, it's a nice little project for your mill, you know, making milling parts for your mill. Yeah, it took a little while, but yeah, it was a fun project. So let's get it calibrated in. I'm going to try a setup like this to calibrate it. I'm not 100% sure if it's going to work, but we'll give it a shot. So I'm going to open the calibration. Touch DRO is very mad because I haven't calibrated it. Going into, just like the other ones, going into Z-axis settings, going down to calibrate, just like we did on the other axes right there. Start the process. We'll do 3 inches because we got a 1, 2, 3 block on end. Locate the bottom edge of the calibration block. You know what? Let me start this over. I want to put the 1, 2, 3, the other 1, 2, 3 block on the bottom because I don't. I mean, the table looks pretty flat, but whoever knows, right? There's a couple little minor divots in there. I'm gonna try something like this instead. So we're gonna go locate the bottom edge of the calibration block. We'll hit continue. Just bringing the knee up. I'm going to bring the test indicator to 0. Pretty much on 0 there, maybe down just a tad. Beautiful. We'll hit continue on Touch DRO. Sampling. I'm not going to move the tablet and show it to you because I'm afraid the screen will change position and it'll reset the procedure like it did once before. Now I have to locate the top edge, so I'll bring the knee down. Crank, 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 crank. Bring this over, down a bit more. Bring this up, hit 0 again. We are pretty firmly on 0. Hit continue on Touch DRO. Sampling again. This should be roughly a 5 micrometer scale as well. We'll see what it comes up with. Still sampling. Yep, that's what it came out. Calculated Z resolution for the resolution for Z-axis, 5080.33 encoder steps per inch, 5 micrometer per encoder step. So I'm going to hit apply. And now our Z-axis should be calibrated. Let's go back into the home screen. There we go. So let's set 0. Well, actually, let me bring it to 0 on the hand wheel. Okay, we're at 0, set 0. Let's bring it down 10 thousandths. Looking at the hand wheel, not looking at Touch DRO. That's just about 10 thousandths, and we are, yep, dead on. Wow, okay. All right, folks, I think that's it. This is a pretty easy install. It wasn't too bad. The only real tricky part in this install was the Z-axis, because we had to machine these spacers, different thicknesses. We had to kind of cut them at an angle to match the angle of the knee, but it wasn't so bad. I mean, you can see everything works just fine. Turning the X hand wheel, turning Y. I only have 2 hands, but you can see I'm turning Z now. So it seems to work great. Love it so far. Haven't really gotten into the user interface. There's a whole lot of features in here that I'm probably going to have to spend hours just trying to figure out and learn. I haven't used a DRO since probably the early 2000s, about 20 years ago. And it wasn't anything nearly this sophisticated. It was just one of those, 7-segment display ones without any sort of intelligence to it. So this is like orders of magnitude more sophisticated. So it'll take me a little while. Let's see. Next step, I got to mount the Touch DRO computer, the actual scale adapter to the side of the mill. I'll do that off camera because that's really not that exciting. But anyway, hopefully you found this video helpful. Hopefully I gave you some ideas on how to mount the scales to your Lagun vertical mill. Not quite the same as a Bridgeport, so hopefully this helps somebody. These mills are out there. They're popular. People seem to like them. So thought I'd give you a little tutorial on how I set mine up. Anyway, if you like this video, please subscribe. Stay safe. Thanks for watching, everybody. Take care.